Hi there. Now this is a follow-up to my first video where I introduced you to the equation of an ellipse, the Cartesian equation and the parametric form of an ellipse. And also I discussed the major and minor axes. So as I say, this is a follow-up exercise to that video. If you didn't see it, do go back and check it out. And if you'd like to try these questions, just give you a moment to pause the video. Now for the first question, we've got to sketch the ellipse 4x squared plus 9y squared equals 36. And you should be familiar with what we discussed in that first video. As a brief summary, what I showed you was that if you had an ellipse like this, the Cartesian equation was given by this equation, and this was the parametric form. You'll notice it crossed the x-axis at minus a and a, and the y-axis at minus b and b. And the longer of these two distances, in this example, this distance here, this is called the major axis, and the smaller one is called the minor axis. Okay? So with this first equation, if we're to sketch it, then I want to put it into this form, and I can do that quite easily just by dividing through by 36. So for question 1 then, part 1, if I divide through by 36, I'm going to get x squared over 9 plus y squared over 4 equals 1. And from this we can see that a squared would be 9, b squared would be 4, so a would be 3, b would be 2. And that helps us sketch our ellipse. It's going to look something like this, crossing the x-axis then at minus 3 and 3, and the y-axis at minus 2 and 2. And you can see that the longer of these two axes is this one here, so this would be the major axis, this would be the minor axis. When it comes to the parametric equations, we can see that a then would be 3, b would be 2. And so the parametric equations would be x equals 3 cosine of theta, and y would be equal to 2 sine theta. You don't have to use theta, you could use any other letter you like. T would be a popular one as well. Okay? So that's that part. Now for the second part, I picked this just because I want to illustrate a further point. Same idea as what we did here. Create 1 here by dividing through by 324. And if you do that, what you're going to get is x squared over 4 plus y squared over 81. And that's going to equal 1. So a squared is 4, a would be 2, b squared is 81, so b is going to be equal to 9. The difference here though is that when we sketch this, it's going to be more elongated in this direction. So our major axis here, the longer of these two axes, would be going from minus 9 to 9. This would be the minor axis in this example. For the parametric form of the ellipse, then it's given by this again, so it's going to be x equals a cosine theta. A is 2, so we've got x equals 2 cosine theta, and y is going to be equal to b sine theta, b being 9, so it's going to be 9 sine theta. Alright, so that brings us to the end of question 1. Now moving on to question 2. In this one, we've got to find a Cartesian equation for the ellipse with parametric equation x equals 4 cosine theta, y equals 7 sine theta. So from this one, when you compare the parametric equations to what we've got here, you can see clearly that a must be equal to 4. Let's just put it down here. A equals 4, and b must be equal to the 7. So when it comes to writing down the Cartesian form, then it's going to be x squared divided by a squared, so that's going to be 4 squared, which is 16, plus y squared over b squared. 7 squared is 49, and that equals 1. Now, if you did forget this particular form, you can always get it anyway just by picking up on cosine squared theta plus sine squared theta is equal to 1, that trig identity. Cos theta then would be x over 4, so if you square it you're going to get x squared over 16. Sine theta would be y over 7, square that, you got y squared over 49. And when you add them together, basically cos squared theta plus sine squared theta would come to 1. Okay? Now for the last question. So for part 3 here, we've got find a Cartesian equation for an ellipse centered about the origin with a major axis of 10 units, and that's along the x-axis, and a minor axis of 8 units. So when it comes to the sketch, it's going to look something like this, with our major axis going from -5 to 5, so it's got a length of 10 units centered about the origin, and the minor axis had to have a length of 8 units, so it's going to go from -4 to 4. So from this we can see that A would be 5 and B would be 4. So for the equation then of the ellipse, the Cartesian one, we're therefore going to have x squared over a squared, that's going to be 5 squared at 25, plus y squared over b squared, b is 4, so that's going to be over 16, and then that's going to equal 1. Alright? So I hope that's been able to give you some idea, as an introduction anyway, on how we can work with the Cartesian and parametric forms of an ellipse.